Yes, previously we have finished the basic concepts of chemistry and redox reactions. Now we start with our next chapter, atomic structure. In this we will be doing with Dalton's atomic theory. See, this was the first successful theory that explained about structure of atom. According to this theory, atom is the hardest, densest and the smallest particle of matter. Okay, of course, it was proved as wrong later with the discovery of subatomic particles, you are aware of. Once again, I am repeating. Atom is the hard, dense and smallest particle of matter. Atom is indivisible and is indestructible. Atom is indivisible and indestructible. Atoms belonging to an element are unique. Means atoms of a given element all resemble one another. Next, properties of elements differs because of uniqueness of atoms. Properties of elements, suppose carbon element properties are different from sulfur element, like that, because of uniqueness of atoms of that particular element. For a given element, all atoms are unique. In this way, it had given a satisfactory explanation about atoms, but Dalton's atomic theory failed in some aspects. What are they? It fails to explain why atoms of different kinds should differ in mass and valency. Atoms of different kinds should differ in their mass and valency. And it also fails to explain the concept of isotopes and isobars, right? So, of course, these are related. So, at the same time, another theory was given, that is, see, with the discovery of subatomic particles later in 19th century, with the discovery of subatomic particles like electrons, protons and neutrons, the concept of indivisible and indestructible matter, indestructible part of the matter about atom was ruled out, because still smaller subatomic particles were discovered with several discharge tube experiment. Nearly at present, nearly 35 or above subatomic particles were discovered. 35 or above subatomic particles were discovered. Firstly, even though there are so many subatomic particles, among them the main particles which should be contained by each and every atom of elements are electrons, protons and neutrons. Electrons, protons and neutrons. So among them, firstly, electrons were discovered by J.J. Thomson in his cathode ray discharge tube experiment. Okay, so cathode ray discharge tube will be taken, in which two electrodes, one is cathode, the other one is anode, are connected, and this discharge tube is filled with gas at low pressure. Means the conduction of gases at low pressures was done here, and cathode, anode. Now, when electricity is passed through these gases or gas present in the discharge tube, they noticed that some particles were emanated out of this cathode and are traveling towards anode. As they are emanated out of cathode, those rays or particles were called as cathode. A stream of those particles are called as cathode rays. And with respect to the electrode to which they are moving, so it was given that cathode rays are negatively charged particles. Cathode rays are negatively charged particles. And to observe that they contain some charge, later they coated this terminal with the fluorescent zinc sulfide screen. So whatever the particles that are emanated out of this cathode, they notice that whenever they strike this zinc sulfide screen, they notice phosphorescence. That illumination can be, means not illumination, phosphorescence. So with the phenomena of phosphorescence, they noticed that these particles were negatively charged particles first of all, later they noticed them as negatively charged particles. Likewise, in a different experiment called an anode ray discharge tube experiment done by Goldstein, Several subatomic particles emanated out of anode traveling towards cathode were discovered. As they are coming out of anode, those rays were named as anode rays. Anode rays. Later, their charge was observed as positive. So in this way, one by one, first electrons, then positive particles, they are named as protons, observed as protons. One by one, these subatomic particles were discovered. So with this discovery of subatomic particles using several discharge tube experiments, the smallest particle, indivisible and indestructible concept was ruled out, which was given by Dalton. Now let us go to some subatomic particles and their characteristic properties. So when it comes to the properties of these subatomic particles, these electron, proton and neutron were basically called as fundamental particles of atom. So what are fundamental particles of atom? Means electrons, protons and neutrons. In your lower classes, you might have studied about this cathode ray discharge tube experiment, anode ray discharge tube experiments, etc. And about discovery of neutrons, now we are going to study. That is by bombardment of nuclides, right? Now let us see, when it comes to the mass of electron that was determined, mass of electron was observed as 9.1 into 10 power minus 31 kg. You have to remember these values. Mass of electron was noticed as 9.1 into 10 power minus 31 kg or 9.1 into 10 power minus 28 grams or 0.000548 AMU, atomic mass unit. As usual, you have to remember these three values. And when it comes to mass of proton, it is 1.672 into 10 power minus 27 kg or 1.672 into 10 power minus 24 grams or 1.007 atomic mass unit. Recently, atomic mass unit was replaced by the term unified mass. And when it comes to neutron, its mass is 1.675 into 10 power minus 27 kg or 1.675 into 10 power minus 24 grams or 1.008 AMU. Each and every value you have to remember at any cost, because in solving the numericals we have to use these values. For that reason, it is very important to remember this tabular form completely. Next, relative mass, comparative mass. If proton and neutron are nearly of same mass, this is 0.003 is the difference, right? That's why if proton and neutron are taken as 1 and 1 relatively, and in their mass, electron was observed as 1836th part of mass of proton. 1836th mass, 1836th of mass of a proton. Okay, or proton is 1836 times heavier than electron. Okay, you can take like that. If electron is taken as 1, proton is 1836 times heavier than electron, and neutron is 1814 times heavier than an electron. In that way also we can get. And relative charge, comparative charge is, for electron it is -1, whereas for proton it is +1, and neutron has no charge. Next, actual charge of each electron. For single electron, actual charge is 1.602 into 10 power minus 19 coulombs or 4.8 into 10 power minus 10 electrostatic units. Actual charge of electron is 1.602 into 10 power minus 19 coulombs or 4.8 into 10 power minus 10 electrostatic units. Even for proton also, the same charge values. For each proton, we can assign the same value. When it comes to neutron, it has no charge. So this is about mass and charge values of electron, proton and neutron. Now let us study about their specific charge also. So these are the specific charges of electron, proton and neutron. See, specific charge is nothing but ratio of charge to mass value. Ratio of charge to mass value. See, for electron it is what is the charge of electron? 1.602 into 10 power minus 19 coulombs over. Mass of electron in grams is 9.1 into 10 power minus 28 grams. On simplification, 1.6 by 9.1 means 0.176 into On cancellation of 19 with 28, 10 power 9 coulombs per gram. So on simplification it is 1.76 into 10 power 8 coulombs per gram. Right? This is for electron. When it comes to proton, specific charge of proton is 1.602 into 10 power minus 19 coulombs over mass of proton is 1.675 into 10 power minus 24 grams, right? Now, when it comes to this, on division, it is 0.954 into 10 power 5 coulombs per gram. On simplification, 9.54 into 10 power 4 coulombs per gram. This is the value. So, either you can practice them initially, but finally, you have to remember these values, specific charge of electron and proton. Because on this, a few questions are possible on the finding the specific charge. So this is a small question on specific charge. Increasing E by M sequence of 4 particles is asked. Electron, proton, neutron and an alpha particle. What is specific charge? Charge by mass. For neutron, charge is 0. So 0 by something is 0. So among all, the least specific charge is shown by neutron. Okay, least specific charge is shown by neutron. Next, as it is charged by mass among electron, proton and neutron. Electron, you know, it is 0.000548 MU. Proton is 1.007 MU. Neutron is nothing but helium plus 2 ion, means helium-2,4 nuclide. Neutron is nothing but helium plus 2, means 2 electrons were removed, and it's only ionic form, helium-2,4 ionic form. 2 protons and 2 plus 2, 2 protons plus 2 neutrons. Only protons and neutrons are specified. That is called as alpha particle. It is called as alpha particle. Okay, alpha is nothing but helium-2,4 nuclide or helium plus 2 ion. Now, neutron mass is this one. Neutron is also 1.008, and when it comes to alpha particle, it is helium-2,4. Now, among these proton, neutron, electron, proton and alpha particle, because already we calculated E by M of neutron. Among electron, proton and alpha particle, whichever is heavier, its denominator will be more, net charge will be less. Whichever is heavier, its denominator value will be more, total value E by M value will be less. Which is heavier? Proton. Neutron is 0 and 1, proton is plus 1 and 1, electron is 0 and minus 1. Okay, so this is almost 0. Among 4, 1 and this one, 0.000548, which is heavier? Helium. So, as helium mass is more, total value will be less for helium. So, next least specific charge value is shown by alpha. Next, among proton and electron, which is heavier? Proton and then electron. So, increasing specific charge value, increasing specific charge sequence of electron, proton, neutron and alpha particle is neutron is less than alpha particle, less than proton, less than electron. So, which option is mapping for this? So, neutron, alpha, proton and electron. So, it is fourth option. So, like this, sometimes we may be asked again the specific charge questions for competitive exams like Cbse. Another question possible on this subatomic particles is electron was discovered by. See, one may be very perfect, but sometimes they may forget because different names will be given in different reference books. To avoid that, electron was discovered by means, I can give you a shortcut. A pen was manufactured by gold trust corporation, a hypothetical corporation, suppose. A pen. So it is a shortcut. Proton was discovered by Goldstein, and electron was discovered by J.J. Thomson. Neutron was discovered by Chadwick. So electron was discovered by Thomson. Like this. So this is another question based on this subatomic particles. So with the knowledge of these subatomic particles, that time J.J. Thomson had given a new atomic model called as Thomson's atomic model. So putting together all the facts known at that time, Thomson assumed that atom is a sphere of positively charged particles. Atom is assumed as a sphere of positively charged protons, in which electrons are embedded, just like seeds in a watermelon. That's why This model was also named at that time as plum pudding model. Plum pudding model. However, this idea was dropped due to the success of this alpha ray scattering experiment done by Rutherford. You have studied in your high school Rutherford's alpha ray scattering experiment with the discovery of a nucleus in that Rutherford's alpha ray scattering experiment. All these Thomson's atomic model and all the previous atomic models were ruled out. So this is about Rutherford's alpha ray scattering experiment. Rutherford allowed a narrow beam of alpha particle. Rutherford allowed a narrow beam of alpha particles to fall on a very thin gold foil of thickness 4 into 10 power minus 4 centimeter. Rutherford allowed a narrow beam of alpha particles to fall on a gold foil of thickness 4 into 10 power minus 4 centimeters. And some observations were also given by Rutherford with this. He noticed that he determined the subsequent path of these particles with the help of this zinc sulfide screen. Here he had placed some zinc sulfide screen here. The purpose of taking zinc sulfide screen is whenever it was hit by a charged particle, it emits light. Okay, with that we can identify that some particle is striking the zinc sulfide screen. See, and finally what happened? Rutherford allowed a narrow beam of alpha particles to fall on a very thin gold foil of thickness 4 into 10 power minus 4 centimeters, and he determined the subsequent path of these particles with the help of zinc sulfide screen, fluorescent screen. The purpose of taking zinc sulfide screen is it gives off a flash of visible light when struck by a charged particle, especially here alpha particle. Alpha particle is helium plus 2 ion, as I said earlier. Helium plus 2 ion, it is ion, charged particle. Like zinc sulfide screen has one more important property. It has a remarkable property of converting kinetic energy of the particle into visible light. Converting kinetic energy of the particle into visible light. Actually, purposefully Rutherford used these alpha particles because they are relatively heavy, resulting in high momentum. Alpha particle among alpha, electron, proton, neutron, all these known charged particles that time, alpha particle is relatively heavy, resulting in high momentum. And finally, what are the observations given by Rutherford in this? Majority of alpha particles are passing straight through the gold strip. Majority of alpha particles are passing straight through the gold strip. A few particles are getting reflected at an angle more than 90 degrees, and a few particles are getting reflected at an angle less than 90 degrees, like that. See, very few particles are deflected backwards through an angle greater than 90 degrees. Actually, the main observation was very few alpha particles were deflected back through an angle greater than 90 degrees, and among those many deflections, some were even scattered in the opposite direction at an angle of 180 degrees. See, this alpha ray was scattered, deflected at an angle of 180 degrees. By looking at this observation, Rutherford was really shocked. You know why? He felt it like when a shell, 15-inch shell was fired at a piece of filter paper, and the shell is striking the filter paper and coming back to the shooter, then what will be the surprise? In such a way, Rutherford surprised by looking at this experiment. So he was surprised that why some particles, very few particles, are exactly deflected at an angle of 180 degrees. Okay, so these are the observations given by Rutherford in his alpha ray scattering experiment, based on which he had given some conclusion. So now, what are the conclusions given by Rutherford in his Rutherford's alpha ray scattering experiments? About the conclusion is, the fact is that most of the particles are passing through the atom means most of the atom is empty, it is hollow, right? Most of the atom is empty. See, and a few particles, this is the first point, most of the atom is empty. The next point of conclusion is, a few particles which are nearing the center of the atom were deflected at angles, means they are facing some repulsion with the light charged particles. particle. Suppose this alpha ray is getting reflected here means in the surroundings it is facing some repulsion from the light charged particle. What is the light charge? This is alpha particle. Alpha particle means helium plus 2. So as positively charged helium plus 2 is reflected means it is facing repulsion from the light charge, that is positive charge. And in a wonder we noticed that 1 in every 20,000 particles, almost 1 particle out of every 20,000 particles was observed as deflected at the angle of 180 degrees, exactly in opposite direction. Okay, means what? That the center of the atom is located or concentrated with a lot of positive charge. In that way, Rutherford, with these conclusions, he had given his new atomic model called as Rutherford's atomic model. So with these observations and conclusions from his alpha ray scattering experiment, Rutherford had given his atomic model, according to which he had given some postulates. In which first one is all positively charged protons and neutrally charged neutrons were located at the center of atom, which is called as nucleus. So in any atom, all positive charges means protons and all neutrons which are neutrally charged were located at the center called as nucleus. Next postulate is size of nucleus is very small in comparison with the size of atom. For example, diameter of nucleus is about 10 power minus 13 centimeter. Diameter of a nucleus is of order 10 power minus 13 centimeter, whereas the diameter of atom was observed as 10 power minus 8 centimeters. Means what? Atom is 10 power 5 times that of nucleus. See, nucleus is such a smaller in space when compared with that of atom. Most of the space outside the nucleus is empty. Another point that was given in Rutherford's postulates are most of the space outside the nucleus is empty. Right? The next postulate is electrons equal in number to the net nuclear positive charge. Nucleus has how many positive charges? An equal number of electrons revolve around the nucleus with high speed in various circular orbits, according to Rutherford. And the centrifugal force arising due to the high speed of electrons. Electrons are revolving around the nucleus with high speed. So the centrifugal force will be arising, right? Centrifugal force arising due to the high speed of electron balances the Coulombic force of attraction of the nucleus. Nucleus is showing some attraction on the electron. Centrifugal force arising due to high speed of moving electron balances the Coulombic force of attraction of the nucleus, and the electron remains stable in its path. Stably, it is moving around the nucleus in its path. This was postulated by Rutherford. Thus, according to Rutherford, an atom contains a nuclear part and extranuclear part. Nuclear part and extranuclear part. Right? If an alpha particle approaches the nucleus, target nucleus, if an alpha particle approaches the target nucleus in such a way that the impact parameter is 0, then it is deflected by 180 degrees. At that moment, kinetic energy of alpha particle will be equal to potential energy of the system. So kinetic energy of the particle is half mv square. Potential energy is Q1 Q2 by R. Right? So 1 by 4 pi epsilon naught into Q1 Q2 by R. Q1 means nucleus charge. Z is atomic number. E is charge of electron. And this is 2 electronic charges are from helium. And R is the minimum distance of distance of closest approach. Here that R is called as distance of closest approach between electron and the nucleus. So these are the postulates given by Rutherford's atomic model. But in a contrary, Niels Bohr had raised some what's that called as drawbacks in these Rutherford's atomic model. Let us discuss about it. So let us discuss defects of Rutherford's atomic model. Means what are the main defects? Means the distance at which electron revolves is not specified. Means no data is given about the distance, no data, exact position of electron. Distance means exact position of electron from the nucleus is not specified. Means radius of the orbit in which electron is moving is not specified, because there is no such task according to Rutherford. Because according to Rutherford, electron is moving around the nucleus in circular path, different circular paths, right? Then the next point is stability of atom is not explained. Stability of atom. If Niels Bohr pointed out that according to the laws of electrodynamics, electron, a charged particle, should lose energy when it moves continuously in this way. And like this, when it loses electron loses when it loses energy, when electron loses energy while moving around the nucleus, continuously it has to move in spiral path, and at one moment it should fall into the nucleus. At one moment it should fall into the nucleus. Then atom should collapse. And as per this calculation also, electron should collide with the nucleus in 10 power minus 8 seconds. But as per the observations, electron is stably, continuously moving around the nucleus. So means what? Whatever Rutherford had given, they have some drawbacks. So to explain these drawbacks, Niels Bohr had given a different atomic model, which we are going to discuss in our next session.